Good afternoon. Can you all hear me? Hi. Any feedback? Can you hear me? If you cannot, okay. Thank you. Um, so Mr. Baltman is at a wedding today, so I'm standing in for him. So let's get to the lesson. I'm going to start sharing my screen now. Okay, can you see the PowerPoint presentation? Sorry, I'm now new to this, the first time I'm doing it, so I'm not as familiar with this as Mr. Baltman. Just indicate, can you see the PowerPoint? Okay, Christian says he can, Keen says he cannot. Not anymore. Okay, perhaps I need to actually okay, I hope you can all see it now. Perhaps I need to actually be in the PowerPoint for it to show. So, let me just see what's the feedback that I'm getting now. It's blank again, it's white again. Okay, I'm in the PowerPoint now, right at this moment. Just let me know whether you can see it, and then I'll know whether it's in fact actually a question of me just having to be on the screen itself. Blank. No. Why is that? Okay, I'm just going to stop the screen and start again. Let's see. Let's try again. Okay, can you see it now? I'm going to do it not in presentation mode, perhaps that will help. I am streaming the PowerPoint. Do you think I should rather do my screen? Okay, let's try that. I'm going to follow Christian's advice. Let's do my whole screen. Okay, now you should be able to see it. Does this work? Because I'm now streaming my whole screen. Okay, I'm just quickly going to look at the feedback. Okay, brilliant. Okay, so this is how we're going to do it. Great, sorry about that. Okay, let's get started. So today's lesson is about operators. Before we get to the lesson, I'd like to know whether you managed with the homework. The next slide actually shows the solution, so I'm going to stop before the next slide and first discuss whether you managed with the solutions. You can type in the text channel, just let me know whether you could solve both of the homework problems. Keen says he could, Ishmael could. Okay, it seems like you all managed. Great. Okay, thank you. So I'll show you what we had in mind and then you can just check whether you did the same. So I think the first question said you had A is something like dog and B is cat, and you had to write some code that if you print A plus B, if I do this now, I get dog, comma, cat. And here you are supposed to write some code without just reassigning these variables. So you're not allowed to go, oh, okay, now let's make A cat and B dog. So you're prohibited from doing this. But still, using variables, you had to write some code in here that would make this output the other way around, cat dog instead of dog cat. So the way to do this, and I'm surprised you could all do this, is to say, good, so you cannot see the live stream. Do any of the others have the same problem? Okay, it seems like the rest can. Goed so. In the voice channel, to the right, at the right hand side of my name, you'll see there's that live sign. If you click on that, another window will pop up where you can click a button to view the live screen. So just try that using that live sign to the right of my name in the voice channel. Okay, let's get back to the homework. So what we wanted you to do was to do this, to make a third variable and say, okay, let's make CA. So C is now dog. And then you can say B equals C. Okay, so B is now also dog. And then you can say, before you do that, sorry, you say make CA, then you say A is B. So you make A cat, and then you make B C. So you make B dog. Okay, if we try this, hopefully the output will be cat dog, otherwise I've made a mistake. Let's run this, there we go. So this was what we hoped you would do. Using a third variable C, you do these 3 assignments that allows you to swap the two. Well done. If you did this, very well done. You couldn't simply do A is B and B is A. Okay, Christian, I'll ask you what you did just now. I just quickly want to explain why this wouldn't work. If you simply did the following, A is B, B is A, why would this not work? Because the first statement would assign the value cat to dog, to A. So A would now be cat. But if you then say B is A, remember that A is already cat after this statement is executed. So B would also be cat. So if we did this, A is B, B is A, and I were to print it, you would get the wrong output. You would get cat, cat. So that is why a third one is required. I just got a message there. Did you do this? A, B equals B, A. Is this what you did? Okay, this is also correct. Very clever. You guys are too clever for me. You sent a screenshot. Okay, let me quickly check what you sent me. Oh, you simply did it like that. Okay. Not quite what we wanted, but that is, for the question we asked, that is a good solution. So well done, Christian and Mangalisu. Well done to you also. And of course the rest of you who did it the way we wanted you to do it. Our way is not always best, so if you can do it in a different way, that's also fine. I think the second question wanted you to prompt a user for a name. So you would do input, enter, whoops, my keyboard is set up. Do that, enter your name, and then you had to get the person's age, age equals and this you had to make an integer. Like that. And then you had to tell the person how old he was 1 year ago. So you could use the same variable, just say age is age minus 1, and then print the final message with the person's name, you were, and then the age. But the age is now an integer, and since we're concatenating it to a string, we need to make it a string. Years old, last year, something like this. I can't remember the exact wording, but I think this was more or less what we wanted. So let's enter my name, my real age. I'm 23. There we go. So it tells me that I was 22 years old last year. So this is more or less the solution to, of course, Ricardo. What, you thought I was 19? Okay, did you all do something similar to this? Okay, I think this was probably the easier of the two questions. Okay, good. Okay, I'm glad that you're doing the homework and generally finding it easy. Hopefully one of today's problems would at least be somewhat challenging. And at this stage, I'd just like to remind you, I know many of you have done some programming, and that what we're doing right now is actually very basic for you. If you consider yourself to fall into that category, please go onto the internet, do the Programming Olympiad questions from previous years. I can guarantee you that you won't find all of the questions from all of the years easy. So do them until you find one that's challenging that you cannot do, and then during the Wednesday sessions, please ask about them so that you can also benefit from what we're doing even though you're more advanced. Okay, so having looked at those problems, let's continue with the lesson. So this is basically what I discussed right now. Let's go to arithmetic operators. So what are arithmetic operators? They're the ones that you're very familiar with. Plus, minus, multiply, and divide. And of course, because we write programs to solve solutions, we'll do many calculations and use these. Now, plus and minus are easy because they're on the keyboard. So if you want to add two numbers or subtract, you use the plus or minus symbols on your keyboard. However, there are no multiplication and division operators on the keyboard. This multiplication is not equal to an X. It's another symbol altogether. So we have two different ones for those. For multiplication, we use an asterisk, and for a division, we use a backslash. So let's try something. Do you all have your PyCharm editors open, or another editor if you're using another one? If not, please open it and then create a new file. You can call it whatever. So I'm currently working in a project that I just called homework, which isn't very accurate because I have a number of things in here now, but doesn't matter. Please create a project and then create a file. Remember, by right-clicking on the project and then saying new Python file. Just create a new file so that you can write some code. Okay, I'm gonna read the feedback. Everyone says yes. There's some additional messages. No. Okay, so I'm just gonna give a minute or so. Everyone, please ensure that you have a new Python file in front of you where you can write some code. Ricardo, you seem drunk, but I understand you. Okay, so I hope you all now have a file where you can write some code. So I'd like you to do the following. Very easy. Create two variables called a and b and assign any numbers to those two variables. And then create any variable c and assign to it the result of any arithmetic operation performed on a and b, and then print the result to ensure that it works correctly. Yeah. So please do that. In the meantime, I'll try to do something similar, but don't look at my screen. Write your own code for now, and then we'll compare in a minute's time or so. Okay, so what we had in mind was just something like this. A, any value, B, any value. Here is one of the four possible arithmetic operations that I could perform between the two, assign my result to C and print it. If I run this application, I get 60. And you can check that it works correctly. If I do addition, it should give me 17. If I do subtraction, it should give me 7. And if I do division, it should give me 2.4, I think. There we go. But now, if I were to do, let's say 15 and 5, I divide the two, you'll see that the answer that I get as output is 3.0 and not simply 3. So why do you think this is? Why doesn't Python output 3? I mean, if I were to ask you what's 15 divided by 5, why would it say 3.0 and not simply 3? Ken, you are correct. Ricardo, because Python doesn't omit, but is omit. Okay. It must be an int. Okay. You know what, Ishmael, I think this is actually something that changed. Because I'm pretty sure when I started using Python a number of years ago, when we still used Python 2 mostly, that if I were to do this, I would get 3 and not 3.0. So previously, when you had two integers, now don't quote me on this, but I'm pretty sure this happened. Previously, when we had two integers and you did a division, Python automatically did integer division, which is the same as floor division, which we'll discuss in a few minutes. And it gave you the output as an integer. But with Python 3, which we're using now, it assumes the worst case scenario. Basically, it says, well, if I have two integers and I divide them, I could potentially get a value that can be presented by an integer like this. So this could have been 3. But if the user gives me 15 and 6, for instance, then answer is 2.5, and I cannot represent this as an integer. And therefore, it assumes the worst case scenario, that we can't represent this as an integer, and therefore it always, nowadays, when you divide two integers using the normal division operator, it would give you the answer as a float, whether it has a decimal part or not. If it has a decimal part of 0, it would still display it as 2.0 or 3.0. So that is how Python 3 works. So the result will always be a float number. Okay, so y is 20 divided by 5 equal to 4.0 and not just 4. And the answer is that Python returns a float. So a float is a data type which has a decimal part as well, as opposed to an int, which represents an integer which has no decimal part. So whenever you do calculations in Python 3, you'll have these two data types, either an integer, no decimal part, or a float, which is a number with a decimal part. Okay, refresher. Can you all remember what the difference in output would be between these? Now try to do this without actually typing the code. If you have 5 plus 5, with those two 5s in quotation marks, what would the output be? And if you have 5 plus 5, no quotation marks, what would the answer be? Okay. Okay, you all seem to have more or less the correct answers. Yes, okay. I can see most of you are still with me. Remember, if you do it like this, 5 plus 5 both in quotation marks, then the compiler would see it as two strings, and it would see this operator, the plus, as the concatenation operator, not the plus. So it would simply join those two strings back to back, meaning the output would be 55, 5. Whereas if you do it like this without any quotation marks, it would recognize those as two integer numbers, and it would actually do arithmetic operation, which is usually what we want when we do something like this. So the result would be 10. Good, I see you all said something to that effect. Good. Okay. Now these three special operators. You might not be familiar with them. Those of you who are more advanced might already have heard of them, but perhaps not all of them. So we're going to look at floor division. Another term for this, which I'm more familiar with, is called integer division. We're going to look at the modulus operator and the exponent operator. So let's look at them one by one. Let's look at floor division first. So what floor division does is basically what I believe Python 2 did with the normal division operator. If you give it two integers and you divide, it basically throws away the remainder. So the floor of a number means after you've divided a number by another number, you throw away the remainder. So for instance, 24 divided by 5 would be 4.8. So the floor of 24 divided by 5 would be 4, because we throw away the 0.8. Another term related to this is called the ceiling, the opposite of the floor, which always rounds up. So if I were to do 24 divided by 5 and I take the ceiling of that, the ceiling would be 5. Of course I get 4.8 and I round it up to get 5. But what we're going to look at today specifically is the floor division operator. Okay, so normally if you do 24 divided by 5, normal division, the result you'll get is 4.8. However, if we change the code, 24 divided by 5, Ricardo, how would you use it? Do you mean when would it be useful, or how would I calculate it? Okay, when would the ceiling be useful? One place where I can think the ceiling would be useful is, for instance, let's say you're using the traditional way to calculate prime numbers and you want to test all numbers up until the square root of a number, but you want to ensure that you don't miss a number, and also the iterator doesn't allow you to give a float as the end point. Then I would possibly use the ceiling of the number. So, for instance, if I want to calculate whether 24 is prime, well, obviously it's a bad example because 2 would already tell you that it's not prime by checking 2. But if you want to check all the factors of 24, or check all the numbers from 2 upwards to see whether they're factors of 24, then you would check all the numbers up to 5 potentially, which would basically be the ceiling of the square root of 24. So that is where one example where a ceiling can be useful. To get the ceiling of a number, if you import the math library, there's a ceiling function. However, in the Programming Olympiad, you're not allowed to import any libraries. So one way to get the ceiling would be to calculate the floor, and if the floor is not the same as the actual result, meaning for instance 24 divided by 5, so you can compare the floor, which is 4, with 4.8. If those are not the same, then you add 1, and that gives you the ceiling. Okay, so that's one way to get the ceiling. There might be better ways as well. Okay. Pleasure. Okay, does that make sense? I'm digressing somewhat. Okay, so if we use, to get back to this snippet of code, if we do 24 divided by 5 using the floor division or integer division, then we get the floor. So if I go back here, let's just test that. Let's make A 24 and B 5. Normal division should get 4.8. As soon as I do the floor division, then I should get an output of 4. And another thing that you'll notice is I get 4, I don't get 4.0. So floor division actually gives you the output as an integer, not as a float any longer. Because the Python compiler or interpreter is clever enough to know that this operator will always yield an integer. There's no way that this can give you something with a decimal part, so therefore it returns the answer as an int. Okay, are you all with me? And there's silence. Everyone's off playing a game. Good. Some feedback. Thank you. Thank you, thank you, thank you. Okay. The modulus operator. This is one that you might not be familiar with. Some of you might. But but I'll be surprised if all of you are familiar with this one. So what the modulus operator does is, I'm not going to use the slide, I'd rather just explain it with code. So let's look at this screen. Let's see what A modulus B is, if A is 24 and B is 5. And then I'll explain. We get 4 back as an integer again. Okay, so what the modulus operator does is, I always explain it to my students in terms of someone who's at a school with a number of sweets in his lunchbox, and he divides it between his friends. So let's say Ricardo goes to school, he opens his lunchbox, and he finds that there are 24 sweets in there. He has 5 friends. So what Ricardo does is he decides he is going to divide his sweets among his friends. So the 5 friends line up and Ricardo starts handing out all the sweets. But Ricardo is a fair friend, so he's not going to give one friend more sweets than any other friend. So he continues giving every friend sweets until he can't give all of them another sweet. So basically, he takes 20 sweets and he distributes it among these 5 friends, giving each friend 4 sweets. How much does Ricardo then have left after he evenly distributed his sweets among his friends? Okay, so he gave each of the 5 friends 4 sweets, which means he handed out 20 in total. Initially he had 24, so he would have 4 left. And that is exactly what the modulus operator gives you. It divides B into A, and then it throws away the result, but just keeps the remainder. So let's try this with 2 other values. Think of any values. Let's say 17 and 3, for instance. You've got 17 sweets, 3 friends. Okay? If you give each of your friends 5 sweets, then you would have distributed 15. So how many would you have left for yourself? You would have 2 left. So if you run this, you see that 17 modulus 3 is 2. So just to repeat this once more, the modulus operator gives you the remainder after you divide 2 numbers by one another. Okay, so 17 divided by 3, let's add this here as a comment. 17 divided by 3 is 5, remainder 2. So 17 modulus 3 is equal to 2. The modulus operator gives you the remainder only. Okay, so I hope this is a new operator for some of you, something you haven't used before. And I'm going to show you why this is a very useful operator in many scenarios. Okay, so they do an example here of the modulus operator. 20 modulus 5, what would the answer be? You can type it in the chat. Next time I see you, one that gives a correct answer first can get a sweet. 20 modulus 5. Zero. Christian, you are the winner of a sweet whenever I see you again. I hope I never see you again. Otherwise I'd better get a sweet. Okay, you're all correct. Well done. So 20 modulus 5 would be 0. 19 modulus 5? Yes, well done. Okay, you all have the idea. You actually grasp this much faster than my average student does. Well done. Okay, so you get the idea. It just shows your 19 modulus 5 is going to give you 4. Okay. Now, here is a bit of a challenge for you. Okay. So this is one place where the modulus operator can be used. So if I tell you that I have 100 seconds and I ask you to break it into minutes and seconds, well, 60 seconds is a minute, so I have 1 minute and then I have 40 seconds remaining. Okay. If I ask you how many hours, minutes and seconds are contained in 4,000 seconds, how would you do that? Can you give me the answer? Are any of you good with mental arithmetic? I can do this in my head. I trust some of you can as well. You can give me the answer, or you can tell me how you would go about calculating this. So you've got 4,000 seconds. How many hours, minutes and seconds is that? I'll give a minute or two for you to think about this. Almost. Almost, Isma, unless I think you're out by the smallest amount possible. Yes. Okay. Ismail typed the answer there. Okay, so Ismail, how did you do this? Yes, correct. Well, you didn't see Ishmael's answer, so it's still impressive. Well done, Christian. Okay, just to save some time, I think I'll comment on how I would go about solving this. Okay, so how many seconds in an hour? Well, there's 60 in 1 minute, and there's 16 minutes in an hour, so there's 3,000. Ricardo, I think you probably had the right answer, but you typed it wrong again. So there are 3,600 seconds in an hour. 60 times 60, yes. Okay, so we know that there's 3,600 seconds in an hour. So how many times does 3,600 go into 4,000? Only once. Yes, correct. Okay, so yes, okay. So that's the first part of our answer. Okay, so we know we have 1 hour. Okay, so how do we then see how many minutes and seconds remain? So what we need to do is we need to see, after we've taken basically subtracted the 3,600 from here, which we already identified as belonging to the hour, how many seconds are left? Okay. So we could have done that with subtraction. Or the shortcut is to use the modulus operator. Because what would 4,000 modulus 3,600 give you? Yes, well done, Keen. So if I've got 4,000 sweets, 3,600 friends, each of them get 1 sweet and I'm left with 400. Yes. Okay. So this modulus 3600 gives me the remaining sweets. Okay. So I take the remaining 400 and I want to see how many minutes I can get it into that. We've already done the hours. So 400 to integer division divide by 60 gives me 6. Yes. So that is the second part of the answer. We have 1 hour, 6 minutes. Then we do 400 modulus 60, and that would give us 40, which would be the last part of the answer. Okay, if all of you didn't follow this 100%, don't worry. My students always take a while to grasp this, so you can go over this again. But here is a solution using a combination of floor division or integer division and the modulus operator to give us the answer. So first we get the number of hours by doing integer or floor division by 3600, because there's 3600 seconds in an hour. Then we update the amounts of seconds remaining by using the modulus operator, also with 3600, which would give us 400. Then we do integer division by 60 to get the remaining minutes, and we use the modulus again to update the amount of seconds that's remaining, which would give us 40, because we have 400 modulus 60. Okay, so this is an example of where a combination of floor division and the modulus operator can be useful. Now this is a pretty simple example, and you might argue that you could have done this in your head without needing to do that, and it's true. However, if you look at the first homework problem of today, which we'll get to in a few minutes, that is also one we'd like you to do. Record. Okay. That's also one we'd like you to do with a combination of floor division and the modulus operator. It's one where you basically calculate if someone needs a certain amount of change depending on the values of the currencies you have in your till. For instance, let's say and you have 5 Rand, 2 Rand and 1 Rand coins. Which combination would be the best to give the person the amount of change that he needs with the smallest number of coins. So that is another place where you can use this. And in the homework problem, again, you don't have that many different values, but you can imagine that if you actually use all the different values in the Rand currency all the way up to 200 Rand, that doing everything in your head every time or using another way could take quite a while, whereas combination of floor division and modulus operator is a fast way to solve that. So hopefully this week you'll do the homework and actually use the same principle we used here. For the moment, don't worry, I know the output here at the bottom is not 100% correct. If we output time, we want it to show 01 colon 06 colon 40. In the next lesson, we'll look at formatting our output. But don't worry about that for the moment. Okay, let's quickly look at the second special, actually the last of the 3 special operators. We've already covered floor division and the modulus operator. The last one is the exponential operator. I think if you import the math library, then there is one for that calculates the power between 2 numbers, but actually it's not really necessary because we can use the double asterisk to calculate a power. And keep in mind that the operands on either side of this operator do not need to be integer numbers. So for instance, if I want to calculate the square root of something, which exponent would I take? If I want to know what the square root of 10 is, how would I do it? Let's open a new code. A is 10. I want b to be the square root of 10. How can I do that using simple exponent? I think Keen gave the correct answer there. Remember that square root is simply something to the power half. So if I do a to the power 0.5 and I print b, then hopefully I would get the square root of 10, which if I do a very quick mental calculation, 3.1 times 3.1 would give me 9.61, whereas 3.2 times 3.2 would give me 10.24, so it would be somewhere between 3.1 and 3.2. Okay, yeah, 3.162277. Okay, so you see that we can even do square roots or cube roots or anything else as well with the exponent operator. Do you all follow? Are you with me? Good. Any questions at this stage before I continue? I just want to ensure I didn't leave anyone behind. Okay, I'm getting a combination of yeses and no's. I hope the yeses are yes, you're with me, and the no's are no questions. Okay. So I'm going to assume that because I'm a positivist, and then I'll continue. Is there a way to input an arithmetic operation using the input function? I don't think there's an easy way to do that, Ishmael. That's an interesting question. I cannot answer you immediately. I've never wanted to do something like that. But I'll try to find out for you. I'd be surprised if no one on Stack Overflow has asked that question yet. Keen says you can. Okay, Keen, show us. You'll need time. Okay. Ismail, I think if the question is, can you specify which arithmetic operation to use by getting input, then you can do it, because then you can write a series of if statements saying, if the user says this, then do that, etc. Whether you can input it directly is another question. That's what I assumed you asked. But yeah, I think for now we should continue with the lesson, and I think Ishmael's question is whether there's like a direct way without basically reading it directly and using it as such without using a series of if statements or conditional statements. So yeah, so I'm not aware of that, but I think we should discuss, I'll look into it, and I think we should discuss it later. Okay. Okay, so the exponential or power operator, a double asterisk b means a to the power b. So if we have 2 and 5, a is 2, b is 5, then say c is a to the power b, then if we print C, then it should be 2 to the power of 5. 2 times 2 times 2 times 2 times 2, which should be 32. And if we, let's test some mental calculation. If I make this 20, what would the answer be? Okay, well, you should actually be able to calculate this in your minds. 2 to the power 10 would give you, let's see, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. No, so 2 to the 10 is 1024. If we multiply that by itself, I think we get the following. 1 million, what would it be? 48,000, 048, 576, unless I'm making a mistake. Let's see. There we go. Okay. Yes. Correct. That is indeed what we get. Okay. You guys should work on your mental arithmetic. Okay. So we can do to the powers with that operator. I think the important thing to take away is that you can also do square roots, and that the power doesn't need to be an integer number. You can do something to the power 0.782 if you want to. Okay, the last part of today's lesson are assignment operators. Now you've already done the default assignment operator. Remember, the equal sign in programming does not mean equal to, it is an assignment operator. And all of the ones we're going to look at now also contains the equal signs, but with a little extra. So this is a list of additional assignment operators over and above the default one, which you're already familiar with. And you'll see that they're all the operators that we covered today, concatenated to the standard assignment operator. So what do these do? Let's have a look. Let's explain it through code instead of words. So if I have A equals whatever, 19, and I do A plus equals whatever, 13, and I print A, what do I get? 32. Okay, so I think it's pretty evident what this does. In other words, what A plus equals 13 does is the same as A is A plus 13. It's a shorthand way to do the same thing. Okay, so another thing you'll notice is that all of these assignment operators operate only on an individual operand. The ones we've done thus far all had an A and a B, something on the left hand side and something on the right hand side of it. Okay, we still have a number there, but we only have a single variable, A. So these operators you use when you want to take A and do something to it and take that result and reassign it to A. Okay. Remember, if we read something like this, we need to read it from right to left. So first we take A, we add 13, and then we take the result of that and we assign it back to A. And if we do that, instead of writing A is A plus 13, instead we can write A plus equals 13. You can use this special assignment operator, which would do exactly this for us. And we can change it to anything else. So what is 19 times 13? If If I do a quick mental calculation, that would be 247. Am I correct? Let's see. 247, indeed. Okay, so it's quite clear what this does. It multiplies A by 13, takes the result, assigns it back to A. If I do minus, thank you, Christian, thank you. I'm just experienced. When you're my age, you can also do this. Okay, if we do minus equals, we should get 6. If we do divide equals, what would we get? What is 6 over 13? 0.4, 6, 1, 5. Is it 1.4615 something? Let's see. Yes, okay. I couldn't do the rest of the decimals, sorry for that. But yeah, got the first few. Okay, so that's what that does. We can even do modulus equals. What would the answer of this be? This you should be able to calculate. Ooh, I think you might be wrong, Keen. 6, yes. Okay, so we take A, which is 19, mod 13 is 6, and we assign that back to A. So we should get 6. There we go. Okay, so I think it should be pretty clear to you how all these shorthand assignment operators work. Any questions regarding them, or is it all clear? I'm not going to do examples of all. I think it's pretty clear what they do. Okay? All clear. Thank you. Any questions at this stage? Thanks, my pizza. Great. Okay. Thank you. I'm very impressed that you're all keeping up with me, I must tell you. I don't want to keep comparing you to my students, but when I do this at university, it takes a bit longer often. Okay, so here's some, it just explains what I explained now. I'm not going to go over it again. You can read through the notes. Okay, so here are today's homework, or this week's homework problems. Write a program to calculate the change given at a shop. This is the one I mentioned. Allow the user to enter any integer amount. The shopkeeper can only give 1 rand, 2 rand and 5 rand coins as change. Display the amount of each coin given as change. Okay, now I should mention here that you want to do this in a clever way. Let's say I need 23 rand change. Okay, please don't tell me that you're going to give me 23 1 rands. The idea is to do it in the minimum amount of coins. So if I must get 23 rand, I want you to give me 4 5 rand coins, 1 2 rand coin and 1 1 rand coin. You understand? If your program tells me you're going to give me 23 1 rand coins, like the ticket machines at the Loch Logan waterfront, then I'm going to be very upset. So I want the minimum amount of coins as change, please. The second question is to write a program to calculate the area of a trapezoid. So the user, we give you the formula there. The user tells you the length of the two parallel lines, A and B, and also the distance between them. So the user inputs A, B, and H, and your program needs to output the answer, which is the area of this trapezoid. Okay, so those are your tasks. I don't think they're too difficult. This first one, I would like you to try it without referring back to the notes. By not referring back to the notes and simply remembering that you should use a combination of the modulus operator and floor division, it would force you to think again about what each of those do. And if you can do it without referring back to the notes or looking at our example, then you know that you really understand how to do this. Please do use the modulus operator and floor division. I know you can do it in other ways by doing subtraction and so on, but the specific idea of this exercise is for you to practice using the modulus and floor division operators. So please do it that way. The second one, I think you should all be able to do very quickly. The first one should take you a little longer, but judging by what I've seen from many of you, you might also be able to do that quite quickly. Those of you sitting here in the class knowing all the answers beforehand, please do try some of the Olympiad questions. I want to give you maximum benefit from the time we have, and if you're more advanced, make use of the time to do more difficult problems and get help with the ones that you still struggle with. If you can do all of the Programming Olympiad questions, let me know so that I can enroll you for some advanced course in Russia. Okay, any questions or comments at this stage? Good. Okay, so that if there's no further questions, that brings us to the end of today's session. Sorry for my technical glitches. I'm not as familiar with this as Mr. Boltman. I'll upload the might struggle with question 1. Good. I want you to struggle a bit. Struggling is the only way you actually make progress. If you can do everything without really concentrating or having to think, then you're not, I mean, it's good that you can do this stuff, but you're not really learning anything new. Learning must always take some effort. So please do go and struggle. The notes I'll upload now. Mr. Boltman sent me an invite to the YouTube channel so that I can upload the video recording. Unfortunately, there's something wrong. I cannot access the channel, so it might be that the video recording is only uploaded either later this weekend or Monday at the latest. So please just bear with us. The video recording might not be uploaded today or tomorrow, but the notes are uploaded now. Thank you very much for your time and have a great weekend. Thank you.